Hey y'all, my name is Prashanth Kumar, or PK, and I'm an MCAT tutor at Shemasian Academic Consulting. Today, I'm going to be walking you guys through an MCAT Biochem passage. Now, everyone has their own unique strategies for what works best for them, but today, hopefully by seeing me walk through this section and what I'm doing, you'll gain some insight into what works best for you. You should be taking roughly 8 minutes for each of these science passages, but today we're going to be going a little more in depth and taking more time so you can see exactly what's going on in my head as I tackle these passages. Let's get it. Alrighty, so I've gone ahead and put the passage and the figure on the left and all 5 questions that we're going to go through on the right. So feel free to pause the video here and go through the passage and the questions if you want. If not, let's get right into it. Alrighty. So the way I tackle these science passages is I like to read the paragraph, write a 4 to 5 word summary right next to it, very quick, and go through each paragraph like that. And the reason I do this is because it provides accountability in that you're not going to get lost if you understand what's going on in each paragraph. So it's like a check-in, and it helps you really understand what's going on throughout the entire passage. So let's get right into it and start out. So a common feature of cancer cells is their ability to rewire their metabolism to sustain the production of ATP and macromolecules needed for cell growth, division, and survival. In particular, altered fatty acid metabolism has been found to play an extensive role in cancer pathogenesis. This has resulted in substantial clinical interest in developing therapies that target the reprogramming of fatty acid metabolism. Pharmacological inhibitors of key lipid metabolism enzymes have seen varying degrees of success. All right, so the question we ask after each paragraph is, what is happening? And so in this paragraph, I took that to be change in fatty acid metabolism turns into cancer, and treatment equals inhibition, right? So you don't have to write it out completely, whatever makes sense for you. So if you don't like writing Greek letters like the triangle, instead of delta, you can write out change. I just thought delta is easier, quicker. You're trying to make it understandable for you and quick for you, because those are the 2 most important things. No one else is going to be reading this. So that's a quick summary, and we can go on to the next paragraph. First generation fatty acid synthase, FASN, targeting drugs such as C75, orlistat, and cerulenin initially showed great promise in preclinical studies. In addition to decreasing the synthesis of saturated lipids, they were also found to inhibit tumor growth. However, due to their weak specificity, FASN targeting drugs indirectly activated carnitine acyltransferase, CAT1, in peripheral tissue. Next generation FASN targeting drugs have been found to display higher specificity with limited off-target effects. All right, so again, question, what is going on? And for this, I wrote FASN drugs, strength and weaknesses, so S and W, and I'm just going to write improved, because we talked about these 2 sort of first generation, next gen. I don't want to get too into the details. We just want to have a quick summary so we know what's going on. Perfect. So citrate lyase is an enzyme in the cell cytoplasm that catalyzes the breakdown of citrate into acetyl-CoA and oxaloacetate. Inhibitors targeting citrate lyase, ACLY, have also been of interest to researchers due to the increased expression and activity of the enzyme found in several tumor types. Certain ACLY inhibitors, such as ETC-1002, have been found to be well tolerated and highly effective in lowering LDL cholesterol in patients with cardiovascular disease, thus indicating that ACLY inhibition could represent a well-tolerated therapeutic strategy. So what's happening? I'm just going to write ACLY inhibitors decrease LDL and cancer. I'm going to put a question mark right there. The reason is because we don't know for sure that it decreases cancer completely. It doesn't say it, but it says it's highly effective in lowering LDL cholesterol, and there is increased expression of of citrate lyase in cancer, in tumor types. So I just put a question mark there just so I don't get too confused if it turns out that this isn't that important. But that's just a quick summary of that. And so let's go on to the next paragraph. Researchers are also interested in developing dietary interventions to address altered lipid metabolism in cancer cells. It's been demonstrated that a low-carb, high-fat diet dramatically increases the efficiency of PI3K inhibitors and synergistically reduces the growth of PIK3CA mutant tumors. Figure 1 illustrates PI3K alpha mTOR signaling. All right, so same question as always. What is going on? And so here I found a focus on decreased carb, high fat diets. You can put diets if you want, and that increases efficiency of PI3K inhibitors. Okay, so I honestly might not even put the increased efficiency if I wanted to be as fast as possible. Just drawing the arrow shows that this increases the PI3K inhibitors, but we can leave it in there for our understanding. And so, great, we've done this passage and broken it down. We now have a figure. I am not the biggest fan of going through the figure at the beginning, just because I think you might not understand everything that's going on, and you might not need to if the passage doesn't ask any questions about it. So I usually just look at it, say, okay, we have some signaling, we have a pathway. Great. If we need to come back to it, let's come back to it later. But right now, we have a great understanding of each paragraph, sort of a quick summary. We don't even need to go back to it unless we want to. But I think right now, we're ready to go ahead and get into the questions. Alrighty. So, question 1. The indirect activation of CAT1 by cerulenin may have resulted in which of the following side effects? Weight loss, frequent urination, arterial plaque calcification, or hypoglycemia? All right. So first, we need to understand what is CAT1. And if we don't understand that or know that from the beginning, we can look back into the passage, and it actually mentions it right here. Carnitine acyltransferase. Now, I'm not a huge fan of highlighting. I don't think it's super necessary, but if you're trying to hone in on certain parts of a passage, or you like highlighting certain important phrases, go for it. So I'm just going to highlight just to show you where we're looking in this case, but you don't have to do it if that's not comfortable for you. So we see carnitine acyltransferase is activated by these FASN drugs, but what does this do? We should have some familiarity with carnitine acyltransferase in that if you remember, it's related to beta oxidation, right? So beta oxidation, that is what comes to mind. But what does beta oxidation do? Well, it takes our fat stores and turns it into energy. That is the process of beta oxidation, and CAT1 is an important enzyme in this process. Now, we need to look. If we're using up fat stores, right, that needs to be indicated by one of these conditions. But we're also increasing the amount of energy we have available for the body to use if we're getting rid of the fat stores to turn it into energy. So we're looking for something that indicates fat, like fat storage loss, and indicates some sort of increase in energy. Great. So let's go through one by one. Weight loss. So weight loss is actually a good option in my head because I'm thinking, okay, we're using up our fat stores. We're losing something we can use. We're probably going to lose weight, and we're losing our fat in our body. So I'm going to keep weight loss for now. Frequent urination. So I don't recall anything about carnitine acyltransferase in the urinary system or the kidneys. So I think this is one of those answers that's just meant to throw you off a little bit. It has nothing to do with it. So I'm going to cross it out. Arterial plaque calcification. Now, here we got some big words, arterial plaque calcification. I don't really know what's going on, but I'm going to focus on keywords. And I see calcification, right? So in my mind, calcification is related to calcitonin, parathyroid, thyroid. And we don't really have that anything going on. Nothing indicates that in the passage, and I haven't read anything about that in my sort of content reviewing. So I'm going to go ahead and cross that out as well. So now we have hypoglycemia, and I know this is related to sort of energy in that sort of world. Now the question is, I want to make sure I understand what's going on. And so this is important, understanding the difference between hypo and hyper. I wouldn't write this down usually, but if I want to make sure I don't miss this question, I'm going to make sure I understand the difference. And hypo means like a less than amount or a dearth of something, and hyper means the greater than amount, right? So here it's illustrating hypoglycemia, or a less than normal blood sugar level. Okay, so this is the question: would we have a less than a lower blood sugar level in this case? No, we should actually have a greater than normal blood sugar level, considering we're using up our fat storage to turn into accessible energy. So in this case, we're not going to want hypoglycemia, we're going to want hyperglycemia. So we're going to get rid of that, and we have A as our answer. Question 1, done. We're 1 for 1. Let's go. All right, so our next question is question 2. Which of the following is a potential effect of ETC 1002? Now, I don't recall ETC 1002 off the top of my head. I know it was mentioned in the passage, so I'm going to go right back there. And so I see it's right here. ETC 1002, it's an ACLY inhibitor, right? So that's important. And so now we run up and we see, what is ACLY? It's a citrate lyase. It's a citrate lyase inhibitor, right? And what is citrate lyase? Well, we have this entire sentence right here. It's an enzyme in the cytoplasm that catalyzes the breakdown into acetyl-CoA and oxaloacetate. So let's read the answer choices. Accumulation of citrate in the cytoplasm. Accumulation of citrate in the mitochondrion. Accumulation of acetyl-CoA in the cytoplasm. Both B and C. Okay, so here we have like a two-part question. One, it's asking us sort of a molecule, which is citrate, acetyl-CoA. And then it's also asking us for a location, so cytoplasm or mitochondrion. So we're trying to eliminate choices or just look for answer choices that don't support both of these parts, a location and a molecule, right? And so right away, in that first sentence of the third paragraph, we see that it's an enzyme in the cell cytoplasm, right? And so if we're having an inhibitor, it's going to act in the cytoplasm. So we're going to get rid of B and D, right? Because B says it's in the mitochondrion, and D also indicates that we're looking at the mitochondrion since it adds B it has B and C. Now we are left with a 50-50 shot, and so we look at whether we're going to have citrate or acetyl-CoA accumulating in the cytoplasm. So this is where I think it's helpful to think about what's going on. We have citrate turning into acetyl-CoA plus oxaloacetate, right? And this is occurring through citrate lyase. Now, important question. ETC is a inhibitor, right? It's inhibiting citrate lyase. So I'm going to draw a wall here because that's what an inhibitor does. It prevents, I can even draw it as an eye. It's an inhibitor that blocks this reaction from occurring. So if citrate can't turn into acetyl-CoA or oxaloacetate, then what are we going to have? A buildup of citrate, right? So we're going to have an increase there. So I'm going to go with A, an accumulation of citrate in the cytoplasm. And so that is question 2. We are 2 for 2 out here. Let's go. Let's move on to question 3. All right. So which of the following amino acids could not be a potential phosphorylation site for the insulin receptor shown in figure 1? All right, so we are asking about amino acids and phosphorylation. We have to question ourselves. Where does phosphorylation occur with amino acids? That's the first thing. And so phosphorylation occurs on hydroxyl groups. That's something I remember reading about. And amino acids is something we should really, really hammer down. Very important part of biochemistry and chem phys too. But we're wanting to make sure that we're looking for one group that is not a potential site of phosphorylation or does not have a hydroxyl group available. So let's go through it. This is a standalone question. We don't really need anything in our passage. So let's get through it. Okay, so threonine. I'm going to go ahead and draw them out. I wouldn't usually do this on test day because it does take time. You should have these in your head. So threonine, that's what the side chain looks like. Tyrosine looks like this. Okay. Tryptophan. go. NH. And then we got, great, that's tryptophan and serine. All right, so we've got all of our side chains right here. And go through them, make sure you can draw these out, understand what's going on. Make sure you know the 3-letter and 1-letter abbreviations. But here we have all of our side chains, and we're looking for one that doesn't have the OH group. And I think it's pretty obvious. We have an OH group here, an OH group here, and an OH group here. So we're going to choose C. Tryptophan, it does not have this, and so this is not able to be phosphorylated. Great. We're 3 for 3. Let's go. Come on. And so let's go on to question 4 now. All right. Perfect. Question 4. Based on the information provided in the passage, why might a low-carbohydrate diet reduce tumorigenesis? Low-carb diets would increase blood insulin levels, thus inhibiting AKT. Low-carb diets would increase blood insulin levels, thus inhibiting P1K3A. Low-carb diets would limit blood insulin, resulting in increased AKT activation. Low-carb diets would limit blood insulin, resulting in decreased activation of P1K3A. All right, so we have another 2x2 question in that we have 2 parts. We have to know what's happening to blood insulin levels and AKT activation, or one of these parts is activation. Okay, so right away, we should know what happens with low carbohydrate levels, right, and insulin. If we have low carbohydrate levels, we would expect there to be low insulin levels because insulin as activated when we have high carbohydrate levels. But in this case, we only have low carbohydrate levels. So we are going to have low blood insulin levels, right? So right away, we can eliminate A and B because it says increase in blood insulin levels. So now we're down to C and D. And we should look for low-carb diets and what that happens to AKT activation and P1K3 alpha activation. These words, these activations, don't really ring bells straight away, so I should look somewhere in the passage. And I see in this last paragraph and in this figure, it talks about low-carb, high-fat diets, as well as we have a figure that shows this signaling pathway, right? All right. So the way I always go about this is I look for AKT and P1K3 alpha, and I see them right here. We have one here and one here, right? And they're connected by these arrows in a bunch of steps. So now we have to ask ourselves, what's happening? Well, if we decrease our insulin levels, right? That's what we should. If we have low carb levels, we're going to have low insulin levels. Then what's going to happen since they're all arrows to the next part? Well, we're going to have downward, we're going to have a decrease in this, decrease in this, we're going to have decrease downstream, right? If we start with lower amounts of something, we're going to have less signaling downstream. Same thing, if we had increased, then we have increased downstream. So if we have decrease everywhere, we're going to expect a decrease in P1K3A activation, a decrease in AKT activation. And so which one, C or D, shows this decrease? That means we go with D because it has decreased activation of P1K3A. And so that is why we eliminate C, is because it says increased AKT activation, which is just not true. So if we wanted to just draw downward arrows throughout this entire process, really helpful in sort of seeing what's going on since they're all directly related. Perfect. 4 for 4. Let's go. Last question. All right. So the last question, we got some molecules. So the reaction catalyzed by FASN produces which of the following fatty acids? All right. So this is sort of a standalone question in that we need to understand what FASN is doing. Fatty acid synthesis is trying to produce this singular fatty acid. And this is something you should know from your studies of sort of fatty acid synthesis, beta oxidation. The human body can only produce palmitic acid. And if you know, I can write that down for you right here. Palmitic acid, right? Palmitic acid is a 16-carbon fatty acid, right? That is something that's important. I remember that still. And that's the only one that's produced by the human body naturally. So we're looking for a 16-carbon fatty acid with no double bonds. And so we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So A is our answer right away. And so this is what's going on through my head is I have to count each of those little corners to make sure the number of carbons. And so if I count B, I think it's 14 carbons in that one. C and D, we have double bonds, which is not naturally produced fatty acid by the human body. So right away, I can go ahead and call this a standalone question and answer it with my knowledge that I've read up on. So there we go. That is 1 through 5 of this passage. Hopefully that was helpful, and I'm sure you crushed it too. So keep it up. Alrighty, team, we did it. Another fun biochem passage. We crushed it. I'm sure you did great. If you enjoyed this walkthrough, please like this video and subscribe to our channel so you don't miss out on any future MCAT videos. Be sure to also check out our high yield strategies in our MCAT 528 playlist, and click the link in our description to sign up for practice questions sent to you so you can get every last bit of practice in before test day. Happy studying and see you soon.